Okay, we got William Downs, Bridge Group Design Section A leader for Arizona DOT, making CFRP work for bridge rehabilitation.
Hi, everybody. How you doing? I'm obviously the local person here with Arizona Department of Transportation. And a couple years ago, we did our first carbon fiber reinforcement project. I understand our first two speakers weren't as thrilled with it as titanium, but this is where we're at. Our project location, for those of you who are not from this area, we are right in the center. This project is right in the center of downtown Phoenix. If you look at the map on the right, the word Tempe, it's very close to where the airport is if you flew in. And we are at the 101, which is just, well, near the word Glendale. If you went through, drove from the airport here, you probably took I-10 through the tunnel. And the tunnel, if you see in the little map where it says Hans Park, that's that tunnel you drove through. We're very close to, we're in the middle of downtown. To the south of I-17 in here is a lot of heavy industry, including one of our girder manufacturers in Arizona is just south of here. I-17 in this area, the two bridges we're looking at are about 2 miles apart, so very close together. They have 3 lanes of traffic in each direction. Average annual daily traffic is about 100,000 vehicles, and that'd be a lot higher if that didn't always slow down a couple times a day. Truck traffic, as I said, heavy industrial area, we're almost 10% truck traffic. The first bridge we're looking at is I-17 Jefferson Street. This is an underpass. I-17 goes under Jefferson, and we're looking primarily at this first girder, which is above the southbound lane. That girder has been hit 5 or 6 times. And since this is carrying I-17 traffic, occasionally it does get up to high speeds, and the hits here have been very significant, often taking out multiple strands. Also, as you can tell from the area, this is not an area where we can close down I-17 for very long for any type of repair. 19th Avenue is the exact opposite. This is an overpass. So we're looking at a fairly high volume city street underneath. And this bridge, if you can't tell from all the little repair marks, it's been hit, if not dozens, hundreds of times. I think the official term on this bridge is LOTSA. It's just pretty regular. Most of these hits, though, because it's a lower speed road, it is a city street, the damage is less severe. A lot of spalls, occasional damage to the reinforcing inside the beam, and on occasion we'll have a hit hard enough that destroys a couple strands. But we don't have the major multiple strands that we did on Jefferson Street. Because of that, on Jefferson Street, we looked at the one primary girder repair. But on 19th Avenue, we went with, I believe we touched there 11 different girders we did some sort of carbon fiber repair on. And probably a dozen more we did just concrete spall repair. This was the first carbon fiber reinforced, especially for girders that we've done in Arizona. Some of our first questions, do we use the ACI method or the AzDOT method? And then what are we designing for? Shear, flexure, etc. As you can see from 19th Avenue, we did a little bit of shear reinforcement and we did flexure reinforcement. The primary repair we're looking at was flexure. Well, none of these girders seemed to have too much problem in shear, but the issues were in flexure. The other question we came up with, and probably should touch at the end of the slide, but basically was how much do we need to repair? Load rating the bridge probably would have been the best option to go back and determine how much strength to add. However, again, the whole concept of this project was we can't close down I-17. So closing it down for a weekend to do a load test, to come back out, to put the repair in, and load, just wasn't going to be an option. As was mentioned, I think, in our first presentation, these bridges were designed in the 50s and 60s. Our as-built drawings did not have all the information necessary. One of the bridges, we didn't even know how many strands there were, much less exactly where they were. So we did our design strength based upon the load rating. Construction steps for carbon fiber, I believe our last presentation touched on a lot of it. We did carbon fiber wraps. So basically, repair the concrete. Clean the concrete, repair the cracks, restore the concrete section, and then one of the big things, as was mentioned in the last presentation, when carbon fiber wraps fail, it's almost always in bonding. So making sure you have the right surface prep is vital. That's just the way it's going to be. You have to connect it properly. Crack injection, and to make sure your corners aren't sharp enough to cut your fiber. 19th Avenue Bridge. We did shear wraps quite along the edge, and those are the U-wraps you can see. It looks like giant Band-Aids. We did put our U-wraps as a spacing originally. We got this idea from another state with the concept that we'd be able to inspect the concrete behind it easier if we have a space between the wraps. Partway through the project, we discovered this is an issue. It takes immensely more time to install all the U-wraps than it would do one giant U-wrap street. So this was would be a major price increase because of the installation time and the effort to go into it. And I believe on the Jefferson Street Bridge, we did just do the one piece rather than do the U-wraps. Overall, our results, I-17 and 19th Avenue was a structurally deficient bridge. This bridge was no longer structurally deficient after the repair. In fact, I believe for a long time it was considered the worst bridge in the state of Arizona because of this. So we managed to remove it from the rating. At Jefferson Street, the bridge was never structurally deficient. We did consider at that point we were replacing the girder strength, replacing 50% of the girder strength. Fortunately, that girder is an exterior girder and supports primarily the sidewalk. And one of the reasons for that is this, from the first time I gave this presentation, from the time the repair was done to the first presentation, yes, on 19th Avenue, it had been hit again. And this was a matter of months. We knew this was going to happen. This bridge, as we said, it just gets hit. And one of the things you'll be able to see on that is on the right-hand side, that's the 19th Avenue Bridge, and that's one of the girders repaired. You can see the little chips in it. And I think you can also see the clearance sign, 14 feet 6 inches. In a heavy industrial area with huge volumes, especially of truck traffic, it's going to get hit. This entire I-17 route, which is the bypass around I-10, obviously goes back to the 1950s and 1960s as when these bridges were built. It is slated to replace that entire section because almost every bridge in that section has clearance issues. They're all low. The plan to replace these bridges, this entire section, to widen the roadway, has been in and out of the 50-year program now for, I don't know, maybe 50 years. It is currently back out. There is a plan in there, and hopefully it'll be coming soon. So when this replacement will all come, we don't know. But as we also know, when you're looking at some fairly short beams, these are AzDOT 3s and 4s used in most of these, it's very hard to get 2 extra feet of clearance by reducing your superstructure height. So the only real way to increase the clearance is to replace the entire roadway. You see, it's hard to bring an interstate up a couple feet in clearance. The one picture on the left is Jefferson Street, and that is the girder we fixed. And as you can see, that one has been hit again and been hit harder, which also goes to one of the reasons we put in a lot of the extra, so much of the shear reinforcing was for containment. As some of these bridges are hit hard enough, pieces of concrete fall off the girders, just from a safety factor. It works as a nice Band-Aid to stop things from falling, or at least that's what we're hoping for. Lessons learned, we need a little bit more work with our testing. We did have some testing issues. One of the tests we ran into, we actually threw out partway through construction because it just could not be done properly on carbon fiber. Measurement and payment, when we put carbon fiber wraps on, especially when you're going for very high levels of strength, often it'll end up 2, 3, or more layers. The Jefferson Street Bridge had 5 layers of carbon fiber. Now, do you price that as square foot of material or square foot of girder? Or do you do this as a lump sum payment? Big lesson learned is figure that out before you bid the project. Because you know no matter what you figured it out on, contractor's going to use square footage of material. Also, make sure you define all your factors in your design. When we did our original design to make sure that this design method would work, we ended up with about 3 layers for the Jefferson Street Bridge. When the consultant firm that won the bid did it, they had 5 layers. And a lot of that was in the way the calculations of the design. Not only did we learn that, we went out and took our lessons learned, and we actually hired an outside consultant to rewrite our special provisions to try to address all of these issues. Those special provisions have been written for Arizona, and they are in the process now of going through the approval process to become part of our standards. That process has just started, so it'll be going out for a consultant review or external review, as well as FHWA review. Since then, we've also done at least one project using carbon fiber for our pier cap wraps, and we find this we believe this has been a very successful project, especially in method of learning. Sorry to buzz through, but I know people are hungry. Are there any questions I can answer? I don't know if we have basically, the question boils down to is when the carbon fiber gets hit, is it destroyed or is it still, how much strength does it retain? And I shortened the question, but the short answer is also short, and carbon fiber does not survive impact well. So even if the carbon fiber is not torn or broken, impact of carbon fiber, you should assume that it's not holding together anymore, which is this also does account for your development length, which is one of your major factors for your bonding strength. And so how big of a development you have. So yes, in those areas where the carbon fiber has been hit, especially where it's been cut, we have to assume that it's not holding strength in that area. At this point, we have not gone back and looked at those repairs yet. We are looking at methods of repairing. Again, the big issue for repairing carbon fiber is the development length. You got to go with at least pretty significant distances, otherwise you're not really putting strength back in. That's kind of what we're looking at. We're looking for the rest of the life of the girder, assuming it does not get hit. This particular bridge, again, it's the first one we've done. We wanted to learn what we were doing. This was, again, a significant bridge that needed to be repaired. In general, in FRP, okay, this one's only 4 or 5 years old. The bonding does not seem to be an issue, at least as of yet. Obviously, impact damage. The other big issue in Arizona a lot is ultraviolet damage. You have to protect it from the sun, and that's one of the reasons ours are painted, is not just for appearance, but sun protection. But so far, at least the bonding has worked well. Connections have worked well. The only area we've really had failures that we've been able to see is from additional impacts.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.